infinite geometric series. So what does infinite mean? Does not end. What does geometric mean?
Power.
The rule has a power in it, but term to term we are multiplying by the same thing. So if we are multiplying by the same thing over and over and over, and that thing, the ratio, happens to be between -1 and +1, or that its absolute value is less than 1, so something like a half or a third or a fourth, the terms will be getting smaller as we progress. So eventually it will be like we are basically adding 0 as those terms keep getting smaller and smaller and smaller. And so we say that that series does have a sum, that if we would add up everything forever and ever and ever, at some point we're basically going to be adding 0 and it just doesn't change things. If the ratio is bigger than 1, so like 2, that our terms are doubling each time, well, as those keep getting bigger, if I keep adding bigger and bigger and bigger things, I'm going to keep getting bigger. Okay? But if your ratio is some sort of a fraction between -1 or 1, that would cause our terms to be getting smaller, like a half, then we say that series has a sum. And the sum is given by the formula a sub 1 over 1 minus r. And like our other formulas, this does not need to be memorized. So this problem asks us to find the sum of this infinite geometric series. It has infinity on the top, so we can tell it is infinite. It has that power in the rule, so we can tell that it's geometric. And we want to find the sum of all the terms forever. The first thing we need to do is check that it will, in fact, have a sum. And to do that, we need to make sure that our ratio is going to cause our terms to get smaller, or that our ratio is between -1 and 1. What is the ratio in this rule? The 0.7 is the ratio. Whatever's taking on the power, the base of the exponent, is our ratio. So our ratio in this problem is 0.7. So does the series have a sum? Yes, 0.7 is less than 1. So as we multiply by 0.7, the terms will be getting smaller, and eventually it'll be like we're adding 0. So to find the sum, the rule is that the sum is equal to a sub 1 over 1 minus r. How do I find a sub 1? It is 3. How do I find it?
You plug in 1 for
plug in the bottom value. Whatever the bottom value happens to be, we will plug in that value. So that gives me 3 times 0.7 to the 1 minus 1, which does give 3. 1 minus, and we said r is 0.7. You can do this arithmetic on your calculator. If you want to type it all in at once, you need to make sure that you're careful to put parentheses around that denominator. Otherwise, I can do 1 minus 0.7 is 0.3, and 3 divided by 0.3 is 10. So that means if I started adding up the terms of this series, the first term is 3, and then after that we multiply by 0.7 each time to get the next terms. If I added up the terms of the series for the rest of my life, and then I told my children, hey, guess what you get to do for the rest of your life, we're just going to keep on getting closer and closer to 10 and never pass by it. Questions? In this series, we need to first determine our ratio to decide if it has a sum. What is the ratio? -1/4 is what we're multiplying by each time. Since it has that positive negative flip happening, we know we're multiplying by a negative. The bottoms are multiplying by 4, so we're multiplying by -1/4. So does this series have a sum? Yes, the ratio is between -1 and +1. If your ratio is not between -1 and +1, you would just say there is no sum. Okay, so if you would find that you have a ratio of 3, you would just say there is no sum for that. But this one does have a sum. So we use our formula. What is a sub 1? 1. A sub 1 means first term. So our first term is 1 over 1 minus, so that r is -1/4. Be careful with double negative. That's really adding 1/4 to give 5/4 in the denominator. And 1 divided by 5/4 is 4/5, or 0.8. So if I started adding up all the terms of this forever and ever and ever, it's just going to keep on getting closer and closer and closer to just being 0.8.
Wait, will it ever add up to 0.8?
It'll add up to be like 0.8000000000000, and then after the next term it'll be 7.999999999, and it'll just kind of keep on bouncing back and forth between those two, right by the 8.
We don't do arithmetic series.
An infinite arithmetic does not have a sum no matter what. So we only care about infinite geometric. Good question. So first thing we need to do is determine if this has a sum by finding the ratio. What is the ratio? 0.1. So does it have a sum? Yes, because that is between -1 and 1. So sum is equal to a sub 1 over 1 minus r. How do I find a sub 1? It's 2. I find that by plugging in 1. 1 minus, we said the ratio is 0.1. 1 minus 0.1 is 0.9. And this gives 20 over 9 as a fraction, or 2.2 repeating. I prefer the fractions to the repeating decimals. And on your calculator, if you divide it out and get a decimal, you can press your math button, and then the first option is turn my answer into a fraction. So you can just hit that and get the fraction. I prefer the fractions instead of the repeating decimals, but they are both correct. Questions? To determine if we need to know our ratio. What is our ratio? 1/3. We're dividing by 3, but we wasn't thinking about multiplying, so we're multiplying by 1/3. So does this have a sum?
Yes.
Yes. So sum is equal to a sub 1 over 1 minus r. A sub 1 means first term, which is 12 over 1 minus 1/3. So this is 12 divided by 2/3, or 18. So if I start to look at what's happening in this series here, if I start at 12 and then I add 4, that gets me to 16. And then if I add another 4/3 to that, that gets me to 17 1/3. And after just 3 terms, I'm almost to 18 already, really. So that means forever and ever and ever, the rest of these terms are only going to make up the rest of that 2/3 to get me closer to 18. And that's it. All of the terms forever are only going to make up an extra 2/3 to get me to that 18. So the bulk of the weight in a geometric series happens in just the first few terms. And then after that, it's adding fractions that are so small that it's basically like adding 0.
So, like, would it be an easy way to, like, do this if, like, we just added the first, terms that we were given, and then it's, like, super close to 18?
It could give you an approximation, but it wouldn't necessarily give you an exact. I mean, this one works out to be nicely 18, but like on the last one, it was 29ths. So whether or not you would see that that's actually where it was heading to, it would be difficult to tell. But yeah, if it works out to be a nice number, you could kind of tell just by adding up a few of them. Our next problem tells us that we have an infinite geometric series that has a first term of 4 and a sum of 10. We want to know what is the ratio. So it's infinite geometric, so we're going to use this formula. We are told our sum is 10, so we're going to plug 10 in for s. We're told our first term is 4, and we do not know the ratio. So we need to solve this equation for r. To do that, I'm going to multiply both sides by 1 minus r, and that will cancel out that denominator. You could distribute 10 at this point. That is not wrong. It's not even a bad thing to do. I'm just going to choose to not to. And instead of distributing the 10, I'm going to divide by that 10 to just get rid of it. If you distribute the 10 because you're more comfortable with doing that, it's fine. You'll still get the same answer in the end. It's like one extra step. Then I'm going to subtract 1. So that gives me negative r is negative 3/5. Which dividing by negative 1 means r must be 3/5. On these, you know that your r needs to be between negative 1 and 1 because we are told the series has a sum. And the only way for a series to have a sum is if that ratio is between negative 1 and 1. So if you get a ratio that is too big or too small, you know you've done something wrong. Okay, so if you get a ratio of 4, you know it's wrong. If you get a ratio of negative 3, you know it's wrong. It has to be between negative 1 and 1. Questions?
Why did we make it positive when it was negative?
Both sides were negative, so I just divided by a negative 1 to cancel out both of those negatives. Same type of question here on this one. Infinite geometric. We are told the sum is 27 over 5. We are told our first term is 5, and we want to find the ratio. This one is actually a fraction equals a fraction, so what can we do here? Cross multiply. So I get 27 times 1 minus r equals 25. And then like the last problem, you could distribute that 27, but I'm going to choose to just divide by it. And that gives me 1 minus r equals 25 over 27. Subtract 1 from both sides. So negative r is equal to negative 2 over 27. And divide both sides by that negative to get r is positive 2 over 27. So this would not be a particularly pretty series to multiply by 2 over 27 each time. But it does work. Questions? The idea of an infinite geometric series is actually how we turn repeating decimals into fractions. So you know that 0.33333333333 is the same thing as 1/3. But why? Why does that work out that way? And the reason is actually from infinite geometric series. So what we're going to do is rewrite this, giving each repeat its own term of a series. So our repeat is 18. That's what keeps happening over and over and over. So I'm going to say my first term is that first repeat. Then I'm going to add to that the next repeat, which has 2 zeros in front of it, and then the 18. And then the last repeat would need 4 zeros before it, and then the 18. If we think about stacking those up on top of each other, I'd have 0.18, 0.0018, 0.1234 zeros, 18, and those 18s would all line up to recreate this repeating decimal. Okay, so what we're doing is breaking up and giving each repeat its own term of a series. And now it's an infinite geometric series, so we can use our sum formula on it. What is first term? 0.18. Our ratio can always be found by dividing one term by the term before it. Since it's increasing by 2 decimal places, that means our ratio is going to be 0.01. You could find that by dividing the second term by the first term. So on the bottom, I have like $1 minus a penny, or 0.99. Since both of those have the decimal in the same place, we can move those decimals over, which just clears them out. And then reduce our fraction. What do those both reduce by? 9. So that would leave 2 over 11. And if I would type 2 over 11 into my calculator, it should tell me 0.1818181818, etc. Okay? So this is actually why a repeating decimal can be turned into a fraction, whereas an unrepeating decimal cannot necessarily be, or at least not by this same rule. You have definitely earned a gift here today with your behavior and being nice weather and tennis and whatnot. We're going to scratch that out and adjust it to here, which cuts off the last 3 problems, which were the repeating decimal problems. So your homework will only be on the first couple types of problems that we looked at. All right? That homework will be due tomorrow. It will be graded tomorrow.